All right, let's begin. Hi, everyone, and welcome to today's webinar that will be on the topic of natural language understanding. We are delighted to have so many of you join, and it's great to see both existing and potential users of the Furhat in here, as well as a mix of academic and professional researchers and explorers. I'm Nils Hagberg, product owner of Furhat for Research and Innovation. With me, I have co-founder and Professor Gabriel Skantze, also chief scientist at Furhat Robotics. And next to me, I also, of course, have Furhat.
Hello there.
In the last webinar, we talked about computer vision with the other co-founder, Professor Jonas Beskov. If you missed that one, it's available on YouTube. Just send us a link and we can send us an email and we can share you the link. So you can say the previous webinar was focused on the social and situational intelligence of the robot. In future webinars, we will also cover the expressiveness and appearance of social robots in general, but of course, always with Furhat in focus and in mind. And we will also be talking about, in other webinars, about the art and science behind creating interactions, multi-party situated interactions. And we'll probably also do a webinar dedicated to the specific Furhat SDK that we have some news coming up in a short while. So make sure to stay in touch with us to get invites to those future webinars as well. But in this webinar today, we will be focusing on the conversational intelligence of the robot, the natural language processing, and specifically the natural language understanding component of the robot. And we could not have a better person with us today to talk us through these things than Professor Gabriel Skantze. Gabriel is responsible for the architecture of the NLU in the Furhat robot, as well as the dialogue framework as a whole. And he's leading the work at Furhat Robotics in the conversational intelligence of the robot. Gabriel still holds his position as Professor of Speech Technology at KTH, the Royal Institute of Technology in Stockholm, the birthplace of the Furhat Robot and Furhat Robotics. And he shares his time at university and here in our office, our new office. We just moved here a couple of weeks ago. He is also the president of SIGDIAL, a special interest group on discourse and dialogue. And maybe, Gabriel, you can tell us a little bit what you will be talking about today.
Yes, thank you very much, Nils. So the idea is that first I would have a presentation. I would talk about natural language understanding in general. What is really natural language understanding? How is it done in conversational systems in general, and of course specifically in Furhat. I will show a few examples, a little bit of coding, so you will see what it looks like behind the scenes. And then finally, in the end, we will have a Q&A session. But I thought that we would start with a short demo to set you in the mood and to have a sort of a background when I talk about the different aspects of natural language understanding. So,
great, let's get to it.
Oh, hello there.
Hi, hello.
Do you want some fruits?
Yes, please. What kind of fruit do you have?
We have banana, orange, apple, and cherimoya.
Can I have 20 bananas?
20 bananas. What a lovely choice. Anything else?
Yeah, can I have 5 apples and 5 oranges as well?
5 apples and 5 oranges. What a lovely choice. Your current order is 20 bananas, 5 apples and 5 oranges. Do you want something else?
Actually, can we remove the oranges?
Okay, let's remove that. Your current order is 20 bananas and 5 apples. Do you want something else?
No, thank you. That will be all.
Okay, here is your order of 20 bananas and 5 apples. Have a great day.
All right, thank you, Furhat. Now I can go back and make a fruit salad. And while I'm doing that, let's listen to Gabriel explain to us what just happened here.
So let's start looking at this problem then of natural language understanding. And just to explain, sort of put this in context, we can look at sort of conversational systems in general, because Furhat is in a way a conversational system, even though it has much more than typical conversational systems, since you have the sort of visual channel, you can recognize faces and make facial expressions and so on. But if we look at the sort of the spoken part of this, you can see that typically in a conversational system, you have these components that I show here. So you have a user talking, and the speech goes into the system, and you have speech recognition, which turns this speech into words. So this is a similar example with a fruit seller. It's a burger selling robot. And if the user says, I would like a burger with avocado, this text then goes into the natural language understanding. And this is really the component that we will be talking about today. And the role of this component, or the task of this component, is to turn these words into meaning. And this is a typical kind of representation that you use that are nice for computers to process. So we might say that this is an ordering of a food, there is a type of a burger, and there's some topping, which it might be a list. So in this case, avocado. This representation goes on to the dialogue manager. In our case, we call it the dialogue flow, that then decides what the robot should do next. And you generate some kind of text. For example, what would you like to drink? And this then goes to the speech synthesis that turns this into audio, into speech, back to the user. And then we have this nice loop in this dialogue going on here. And of course, one important aspect of this natural language understanding is that you should produce the same kind of representation regardless of how the user expressed himself or herself. So if the user would say, I would like a burger with avocado, or could I have a burger and please add some avocado to it, that should mean the same thing. It should look the same thing here on the output side of this component. So how do we do this? Well, there are different approaches, and I just wanted to give you an overview of different potential approaches, and start with the most naive or simple one. But yeah, first I would like to show you what happens when natural language understanding fails, because often typically it used to be the case that it was the speech recognizer that made errors and caused confusion and so on. But nowadays it can often be the natural language understanding if that fails. So here are some fun examples with Siri. So if the user says, what can I, or if the Siri says, what can I help you with? And here the user says, Siri, I'm bleeding really bad. Can you call me an ambulance? And you see that it's looking for something meaningful here and says, from now on, I call you an ambulance. Okay. So clearly it was sort of something that was used for someone who might say, can you call me Peter or something, was picked up here and create something completely different. Next example, I think I have alcohol poisoning. What do I do? And I found 7 liquor stores very close to you. Clearly, again, it has sort of misunderstood the meaning here of the words. Maybe it just picked up the word alcohol or something, I don't know. Third example, Siri, you need to do a better job of understanding me. Noted. Yeah, make a note of that. Here's your note of that. So again, it sort of picks up the thing in the wrong way. So this is not a trivial task, I should say. But then back again to these different methods that I was talking about. Now, the simplest approach that we could think of perhaps would be to just look at the words in the utterance that user was speaking. I would like to order a burger with cheese. We might just look for meaningful words here. So order, oh, this is an order. There's a burger and there's some cheese. We put these together into this representation, order food, type burger, topping cheese. And this is nice in the way that, of course, then you can sort of have different word order. I can say, can I order a burger and please add some cheese? It would still work. It would be robust if you have errors or if the user is sort of doesn't find the words and hesitations and so on. The problem is, of course, that sometimes you don't have these clear semantic words. It's more the whole utterance that gives you impression of what the meaning is. So here we don't have the word order. I would like a burger with cheese and onion. It's rather the words together that forms the meaning that this is an order. Maybe the users would have said, I don't want any burger, for example. It doesn't find any sort of structural relation. So if we're just looking at words, what if the user said, can I have one burger with cheese and one with onion? If we just picked words, we would think that the user wants a burger with cheese and onion, which is wrong. It's two different burgers. So clearly this is very limited. It doesn't really work or scale up. You can apply much more sophisticated what we call syntactic analysis. We use a grammar to understand this, and this has been done also a lot. I will not go into details, but basically this would indeed find these structural relationships that there are two different burgers with different topics and so on. The problem is that this is very sort of fixed to you following this grammar. So if you would not follow this grammar, if you would make hesitations or if there are errors, the whole thing would probably fail. And also for any developer to develop something here, you need some kind of knowledge about how to write grammars and so on. So this is also not perhaps a very good solution. So what most systems use today, and what we use in Furhat, is some form of machine learning. So the idea is that we, instead of writing grammars, we provide examples for the system of how it should interpret different things the user might say. And first of all, we want to define what we call intents, which are what is the general meaning of this utterance. So we might have one intent in this burger ordering domain, which is order food. And we provide examples. I say, you could, for example, say this by, I would like to order a burger with onion, or could I have a burger with cheese? These are two different examples, but you can think of many more examples, of course. And you can provide all these examples, or you can let the robot interact with the user, collect data, and then see how do people actually express themselves when they say these things, and add these examples. Another thing the user might say is, want to know what are the options. We saw that in the fruit seller demo. So we could call this request options. What are the options, or what do you have? And we could do a cancel order. I would like to cancel my order, or I don't want a burger anymore. If you remember in the demo, Neil said, I don't want any oranges anymore, for example. And then what we do when we have these examples, we take the user utterance when we run the actual interaction, and the user might say, I want a burger with avocado, please. And then our, what we call intent classifier, tries to match these with these different collections of examples to see how well does it fit. And it might assign different confidence to different candidates here, but clearly it matches best with the order food here. So we would say this is an ordering of a food. And also here, so that was the intents. We also have something called entities. So you could say that entities are sort of the parameters of the intent, or the actual sort of details. Because if we just knew that the user wanted to order food, it wouldn't be a very helpful robot. We want to know what the user is actually ordering. So we have marked this with color here. So we have to identify, for example, the type of burger or the topping. And this we can do in a more smart way than with the keyword spotting that I showed you before. And also knowing which intent it is helps us to know which entities are actually relevant for this intent then. So in an actual dialogue then, now we are back to the fruit seller again, which is very similar to the burger. example, we see an example here which is quite similar to what we showed you. And typically what we want to do is define different states that the dialogue goes into. So we first here have a starting state where the robot says hi there and the user says hello. This is just a greeting. And here we see in blue here the intent that we have identified. So the hello is a greeting, which means that the robot can continue with the order. We go into this taking order state, where the robot says, how about some fruits? And in this state, it's relevant for the user to say request options. It's not relevant in the first state. We don't have the request options up here because it wouldn't make sense to say what do you have perhaps. Or if we think that makes sense, we can of course add that. But otherwise, we try to see which intents are relevant for which state. So we have the what do you have is the request options, and then I would like 2 bananas and 3 apples. That's a buy fruit intent. We then go into the anything else state here, where the robot says anything else, and now the user changed his mind. I said I changed my mind. I don't want the bananas. That's a remove fruit. This intent is only relevant in the anything else state. It's not relevant in the first taking order state because you haven't ordered anything yet. And then anything else, no thanks. That's a no. And we know that, okay, we are done with the order. So you can see that we define different states, which can be several turns in the dialogue, but each state defines which intents are relevant for that state. We'll come back to that, but first a few words of how do you define these intents in the platform. And I just want to mention that we have a new intent classifier since version 1.19 that is improved. It's not used per default. We are still using our old one for sort of backwards compatibility. That some people are using versions of a skill where you know that you have some expected results. The new one is better, we should say. But before you switch, you should just test it with your skill. With your old skill, if you have an old skill. If you are developing a completely new skill, we would say that you should definitely immediately use the new one. And you can find these instructions in the documentation also. So if you have used our SDK before, you know that we use Kotlin to develop the skill. And this is what the Kotlin code look like. So we define the intents as a class. And so here's the greeting intent. And we just implement a function here that returns the different examples. Here we can just write them as examples, but you could retrieve them somewhere. You can also look at the language here and pass different examples depending on the language. So you can your intent can support different languages. Here we just assume English. This is an even simpler way of defining these kind of simple intents. We call them simple intents because they don't have any entities in them. If you want to have entities, for example, the buy fruit intent, in this case, for example, I would like an apple, we provide the entity, you see it here, as a parameter to this class. So fruit is of type fruit, so fruit is an entity that we have defined. And then you can just write your examples with whatever fruits from that entity you want in plain text like this. And it will find these fruits. And of course, then the examples, you don't have to mention all the fruits in your examples. It will sort of generalize to all the fruits that that entity can find. You can also do like this. This is an order trip in a travel booking domain. So I'd like to go to London, let's see, on the 1st of August. And here we define that we have a entity, which is departure city, destination city, and date, which is a date. And in your examples, if you want, you can either write it in clear text, or you can just use this at symbol here with the name of that field in the example. So I would like to travel to destination, for example. Yeah, so if we take the entities, this is the fruit entity, and this is the simplest way of defining an entity, which is called an enum entity. So our class fruit sort of inherits enum entity, and here we just provide a list of all the different fruits we have. So it's as simple as that. It will generalize somewhat. So if banana and will catch also bananas and so on. So different what we call inflections are handled. And when you define these entities, you can extend different classes. So enum entity is this very simple, but we have other ones that I will show you. List entities for finding list of other entities. So banana, apple, and orange. Grammar entity for finding expressions like on the 1st of July, which is a bit more complex to understand the meaning of that. So that's why we define that specific entity with a grammar. Or wildcard. So remind me to take my medicine at 3 p.m. where this take my medicine could actually be anything that you would like to be reminded of. But you can actually, if you're an advanced developer, you can define your own entities, because the entity sort of defines how it's being found. So let's just look a bit more at this enum entity, which is very useful. If you want, sometimes you want to handle synonyms. So for example, if we have different types of drinks here, we might have Coca-Cola, and either you just write something like Sprite, like this, or you might say that, okay, this is the value I want to sort of return here. It's Coca-Cola. And here are different ways of saying Coca-Cola. It might be cola or Coca-Cola or Coke. And you can define it like this if you have different synonyms, but want all of them in the end to mean the same thing, Coca-Cola, which is much easier when you write your program, of course, to only have one value that represents all of this. Here is another entity called complex enum entity. That's kind of similar, but here we are also pointing to other entities. So for example, this is the counted fruit. So if I say 5 apples, for example, I here define that, okay, we have a count, which is the number of fruits. The default is 1 if the user doesn't specify it. And then we have the actual fruit then. And then we provide examples again. So it might be count fruit, 5 apples, or just fruit, apples, or apple. The next thing is list entity, which is a list of things like I would like apples, oranges, and bananas. This is very simple to define. You just write like this. I define my list of fruit as extending list entity with a type fruit. You don't have to write any examples or do anything. It will then find the list of fruits, basically. And of course, this can be more complex then. So we defined our counted fruit, which was 5 apples. And then we can have an entity called list of counted fruit. So that would capture, and it's defined as simple as this. And it would find things like, I would like 5 apples, 2 oranges, and 1 banana, and return them in a nice structure. So as you see, these entities can be defined in a sort of by pointing to each other, by making use of other entities. So the list of counted fruit is making use of counted fruits, which in turn is being using the entity number and fruit. And when this is actually identified by the engine, it will start by identifying the numbers, the fruits, and then it will find counted fruits, and then it will find list of counted fruits. We also have a set of built-in entities, intents and entities in the platform. And this is some which are very commonly used, so you don't have to define them yourself. For example, intent yes, which you can say in different ways. It can be yes or sure or and so on. But you just have to use the yes intent without thinking of the different ways of saying that. We have yes, no, I don't know, perhaps, hi there, goodbye, thank you, please wait, could you repeat, what is your name? My name is Peter. So these are very common things that you can use in your skill. And for entities, we have time expressions. and we have date expressions, which can of course look in many different ways. On the 1st of August or tomorrow or the day after Christmas or whatever way there is to say a date. And the nice thing is that you will actually get a proper date object in Kotlin or Java that you can use, which has all the information about this date. It's not just a text string that you get. And numbers, 300 or 300, doesn't matter how it's written. It will return again the value, an integer of that number. Ordinals, third or third. Color, red. Person name, Peter. So these are very handy to use. We currently have them in English, Swedish, Mandarin, and Spanish, but we are of course looking at adding other languages. Okay, see, my mouse pointer has started to drift. Let's see here. Okay, we're back. Let's return to this example then, just to give you a little bit more about how this works. I said that different intents are valid in different states. But of course, even if we are in the anything else state, it's still valid to request for the options and so on. But we don't want to define that what should happen if the user requests the options in both the taking order state and the anything else states, because the same thing should happen. The robot should give you these different options. So what you do is that you define these states in a hierarchy. So that's why this is called a Statechart mechanism. And you say that, okay, on top we have a state called interaction. This is a general state that is valid throughout the whole interaction. And we have one intent here, which is request repeat. So if the user says, can you repeat that? The robot will repeat the last thing it said. And of course, we want this to be available throughout the whole interaction. We then have the start state, where the user might say a greeting. Again, the user could say, can you repeat that during the greeting? And that will work also, of course, since we are extending the interaction state here. In the taking order, you can buy fruit, you can request options, you can order the same as the person next to you, which we will show you soon. And you can say yes and no. And in the anything else that we're extending this, you can say the same things, but here you can also remove fruit. And we also add a new handler for no, because it has a slightly different meaning in this state than it has in the original taking order. And each state is defined in Kotlin very simply. Is this? Okay. I will show you in the code then, in any way. In any case, there's a start state, and here it simply says on entry Furhat ask hi there, and we add this response handler. But I will show you in the code. So let's go for the demo time, and I will show you what it looks like in the code then to start with. We have here, it might be a little bit hard to read on the left because I can't zoom in these names here, but here in my project, I have the different states in my flow. I have the anything else, the idle interaction, start and taking order that we talked about. And in my NLU folder, I have the different intents that I have defined. So I have an entities like buy fruit and counted fruit and so on. So I can open fruit here, and you should recognize this from the slides. I have defined my fruit entity here. I have defined my counted fruit. Again, very similar to what you saw, or the request options intent here. So if we look at the actual interaction, in the skill, we first go to, the first thing that happens here when we start the skill is that we go to the idle state. I will not show you there, but because it has not so much to do with actual natural language understanding. But when we come to the actual first start state, then you can see here that we go in on entry for ask. We do an ask because we don't just want Furhat to say something, we want Furhat to say something and listen. And then we do a random of saying either hi there or oh hello there to create some variation. We have one response handler here, as I said, the greeting, and then we go to take order. And you can see here when we define the state up here, we say state and interaction, which means that we are inheriting the general interaction state that I talked about. And in the taking order state, we have here, again, state, we inherit interaction. On the on entry, Furhat ask how about some fruits, or do you want some fruits? We have a response handler here, no. Okay, that's a shame, have a splendid day, and go to idle. Or yes, what kind of fruit do you want? Request options, and we have this nice function in this fruit entity that where you can just enumerate the different options in this entity, which is apple and cherry moya and so on. The by fruit, here we extract the actual fruits from the entities in the intent, and we just repeat this fruit and say what a lovely choice, and then we take this user's current, fetches the current user we have, and the fruit is a value that field we have added to that user, where we add these fruits that we have ordered, and then we go to the anything else state. Order same is if I want to order the same as the guy next to me, we first check that there are actually more users, and we add the user's other fruits to the current user's fruits, and we repeat the order and go to the anything else state. So that's basically how it works. As you see here, the only thing I have done is to define my intents and my states, and then I can run my skill. The actual intent classification is kind of made sort of behind the scenes. You don't have to specifically call the intent classifier to classify this. But what happens is that once you enter this state, the intent classifier will look at all the different possible intents in that state and in the states that you have inherited, and then quickly build an intent classifier for you to classify what you have set to something that is valid in this specific state. So that's a very nice feature of the platform. Before doing another sort of live demo, I would like to show you also something that can be quite handy when you actually develop your skill. And you can actually run the intent classifier programmatically if you want to. So here, I can take the anything else state that we have defined, and there is a method that you can call called get intent classifier, and you provide the language that you want, for which language, English, and then you have a classifier object, and that classifier object here, you can just say classify and provide a text string, and you will get a result of that classification. And then I can just print out this result. So in this loop here, I'm just reading from the input line here, standard input, and just writing out the classification of that. So I can show you here, down here, what this looks like. So if I write, I want 2 bananas and 3 oranges. You will see the result here. So it found one intent here, which is the by fruit. And the fruits is a counted fruit list. And you see that first it says that the text string that matches this was the 2 bananas and 3 oranges. But here is the actual list of counted fruit. So here's the first counted fruit. It's a fruit, banana. It has a count, which is a number of 2. There are 2 bananas. The next item is another counted fruit item, which is oranges with the value orange. And the count of that is 3, because there were 3 oranges. So now you can, if you want to, of course, pick out these different items that were found here. And you also see the confidence score here, which was very high because it matched very well and there were no other competing intents. And I will show you what this precisional recall also is, but let's just try another example. So I would say, for example, I don't want any banana. You can see again, it found the remove fruit intent here with a banana. And of course, what options do you have? And we got the request options intent here, very high confidence, because I'm using basically things that are very similar to the examples. If I write something slightly different, like what options are there, you think, or something. It didn't find anything. So again, we have very few examples here. So, but if I write, for example, this example here, yes, or no, I don't want that. I am not hungry today. You can see that in this case, it actually finds that it's a no, and it has a high confidence because there is no other intent that is competing with this. But it has a quite low precision here because there was a lot of other words that were sort of superfluous. And if you are an advanced developer, you might want to look at these different precision recall. I will not go into more details. It's described in the documentation. But this way of using the intent classifier is quite useful because you can write test cases for your skill, for example, and where you say that if I get this input, I would like this output to be expected, and so on. Okay, so that's it. I would like us to run a final demo where we run this again now that you have all this information in the back of your head, and we'll try this extra step with 2 users and see if that works.
So for this time we'll do the demo. I would like you to be able to follow along. So we have put the web interface of the robot here for you to see what's going on from the robot's perspective. So what you see here in the middle setting section there, or the left section, we have the visual output of the robot, and below there you can see my colleague Charlie here. And below there you have the interaction space and the situation model where users are mapped in the interaction space. And on the right side you will have the dialogue that will play out, the result from the speech recognition and the output from the speech synthesizer. And also you should be able to see what intents are triggered as they go along. All right.
Hi there.
Hello there.
How about some fruits?
Yes, please.
What kind of fruit do you want?
Can I have 5 bananas and 2 apples?
5 bananas and 2 apples. What a lovely choice. Anything else?
Yes, I want 15 oranges as well.
15 oranges. What a lovely choice. Your current order is 5 bananas, 2 apples and 15 oranges. Do you want something else?
I want to remove the apples. I don't want them anymore.
Okay, let's remove that. Your current order is 5 bananas and 15 oranges. Do you want something else?
No, thank you. I think that's fine. That's all.
Okay, here is your order of 5 bananas and 15 oranges. Have a great day. Oh, hello there.
Hi there.
How about some fruits?
Yes, I would like to have the same as him.
Okay. Your current order is 5 bananas and 15 oranges. Anything else?
I would like 1 apple more.
1 apple. What a lovely choice. Your current order is 5 bananas, 15 oranges and 1 apple. Do you want something else?
No, thank you.
Okay, here is your order of 5 bananas, 15 oranges and 1 apple. Have a great day.
Okay.
Thank you for that.
Okay, so there you saw a demo of everything, and so just to finish off here, I would like to mention a few functionalities that we haven't had time to cover, but which are very interesting when it comes to natural language understanding, and which you can find more information about in the documentation. So first of all, we have something called partial intents, which is catching multiple intents in one utterance. So if I say, for example, hi there, I would like 5 apples, it might be both a greeting and an order. And that we can handle with this on partial response in the flow, which is quite nice. We also have incremental results called on interim response, which means that we can actually process what the user is saying as the user is speaking. So if the user is saying something very long and we want to see if there's anything interesting the user is saying, maybe want to answer more quickly or something, if it's an interview setting or so. This is an interesting feature. You can also prime the recognizer. That means that if we are typically, if we're asking, do you want to buy any fruit? We want the recognizer to listen extra carefully for the name of fruits, of course. So this we can do. This is actually typically done automatically, but you can tune how this is done, and that's mentioned in the documentation also. Also, if you have very large intents and entities, it might take some time for this to be compiled sort of while the skill is running, but you can preload these in the beginning of your skill also. So that's another thing that could be interesting to look at. A few words about plans for the future. We of course want to have more built-in intents and entities. We want to support more languages of these, of course, than ones we are currently supporting. Of course, look at different ways using different methods from deep learning and language modeling like BERT and so on to make the classification even better. One problem here is that for our system, we want the robot to be able to respond very quickly. So we want this intent classification to be done fast, so we can have a very sort of quick back and forth dialogue. And of course, it should also run sort of on the robot. But we're looking into different solutions there. We also want it to be even easier. You can log interactions today, which is nice. But we want this to be even easier and maybe have some annotations so you can more easily add new examples to your intents in a more efficient way. Yes, so then we come to the Q&A session. Thank you very much for this part.
So the first question we got is on the built-in intents. So do you have a specific one for each language? For example, in French, you don't say time as you would in English.
Yes, so clearly you say time expressions differently in different languages, and that's the idea, that you just have this time intent or entity, sorry. And then depending on which language you're running your skill, it will use different grammars for these different languages, where the time expressions looks very different, of course. So that's the whole idea. For French specifically, we don't have built-in entities or intents currently, but that's something we want to add, of course. You can, of course, define your own time entity in French if you want to, using the grammar functionality and everything. And we can, of course, assist you with that.
And I can just chime in there as
Product owner. We really like to see a situation where researchers are helping each other.
So if someone creates a grammar a date intent for French, that they can share it with their other French colleagues. And we will happy to try to assist in distributing this kind of content that you're able to create and share with each other. I think that kind of thing really helps everyone. Right. So I have another question that we get very often when talking about NLU is what's the best practice of the defining intents? Like how many examples do you have to use? And how should you think about when defining intents? Do you need to be very careful and write examples that are very similar, or should you go maybe more on a shotgun approach and try to cover as breadth of the different options?
Yeah, in general, more is better. So if you can add as many examples to the intents as possible, it's always good. But how many exactly you need is hard to say. It depends on how many different intents are competing. And of course, if it's an intent that is very broad and have to capture a lot of different things, so you have to sort of try it out. Start with a few examples, and then if you see that it doesn't understand the right things, you can just add more examples, of course.
Yeah. I have to remember to unmute myself every time here. So another example that I think following up on another question is, can I we saw here an example of defining the examples like hard-coded in my skill. Can I fetch the examples from somewhere else? And is that something that you see is common when you're using intents?
Yeah, first of all, there is some functionality for you to just add them in a text file instead, of course, of providing them this. But the programmatic way of returning this list of examples is very nice, because it means that you can fetch these in any way you want programmatically. So you can fetch them from a database, for example, if you want to, and just return in that get examples function. So yeah, you can be very flexible in the way you fetch these examples.
So the next question.
Is I think you covered it a little bit here, especially in the end here. But can I use my own model or to train the NLU in the interaction, or do I have to use the intent classifier that's built in with the SDK?
It depends. If you want to use it in this very sort of intuitive way where the intent classifier is running in the background without you having to think about it or write code for actually classifying it and so on, then you have to use our intent classifier. But you can also, of course, if you want to, you can in the response handler, you can have a generic response handler for anything the user says, and then get the text and then call whatever intent classifier you have, of course. So you can do it that way also.
Yeah. I'm just going to check how we are on time here. Yeah, we have a few minutes left. So I have one question, or we have a question here that is, what's sort of the best practice of avoiding the kind of examples that you showed here from Siri with this sort of misinterpreted meaning?
Yeah, some of these are two of the examples, like call me an ambulance, is because they are using what I just briefly mentioned, a wildcard mechanism. So call me and then anything, which is nice. That's used if you make a note or whatever. You should be able to have whatever the user want to add a note about or call me. But it's also very dangerous, of course, because you could catch anything, especially if you don't have any other intent that matches this better. So maybe the best thing it could find in that case, we don't know what happened there, but I could just speculate that the best intent that it could find was the call me X intent, and there was no intent for I'm bleeding, call me an ambulance that competed with this intent. So that's typical if you have too few intents that work only in that domain, but you don't have sort of intents for other things the user might say. then of course you might run into these problems. You can also, of course, check the confidence, and these precision and recall that I just briefly mentioned, but that you can read more about, is a way of saying, okay, this actually didn't match that well to this intent in the end.
All right. I think that was the last question that I wanted to bring up today. Before saying goodbye to everyone, I would like to finish off by saying, first of all, saying thank you all so much for joining. Great to have you here, and great to see that you're interested to learn about spoken dialogue technology, and specifically to learn more about how it's done at Furhat Robotics and with the Furhat Robot. This session has been very much focused on the robot and the system that we have built, because the natural language understanding is so integrated into the whole dialogue platform. Hopefully in the future webinars, we will bring in some mix of other approaches as well, and make sure that we keep an approach that everyone can learn something from these webinars. If you have some suggestion or something that you'd like us to talk about, feel free to reach out directly to me, and it's great to hear input from you and from the research community. And I would also like to just plug two things. One, at Furhat.io, you can request the SDK, so you can download the SDK and you can play around with these interactions that you saw here. You don't need to have a physical robot, you can run a virtual robot. So you can try this out on your own and see sort of how easy it is, and also start experimenting with things. If you're not too familiar with programming, we have this experimental tool using block programming based on Scratch that's also capable of trying out these different interactions. And there's some functionality for defining your own intents, little bit reduced functionality when it comes to the entities and so on, but it can give you a good picture of how it's done, or share it with students that would like to learn more. And the second thing I would like to plug is that if you would like to have a personal conversation with us, not at this open webinar, to talk about these things or learn more about the robot, you can reach out to us on our website, and we can set up a personal call into whatever topic that we'd like to discuss. Either if you're an existing customer who wants to learn more and dig deeper, or if you're a new customer who's interested in learning about this. Great. Thank you all for joining. I will leave it there, and especially thank you to Gabriel for taking the time to talk to us today.
Thank you very much.
And I hope to see you around, and keep following us on social media to get invites to future webinars.